Tonight we're going to talk about our ASP.NET Core and clean architecture, with mostly an emphasis on clean architecture. I've given this talk a number of times at a few different conferences and cleaned it up a little bit for tonight. So hopefully it's all good. There's nothing goes wrong with it. Before I get started, I had a few quick questions for folks in the audience just to kind of help me gauge my level of depth I want to go into on different things. How many of you are already working with ASP.NET Core like at work? All right. How many of you like it compared to older ASP.NET? Awesome, isn't it? So much better. Now, if you're a web forms developer and you loved web forms, then you're kind of out of luck because Core doesn't have any of that. But most of the clients that I'm working with these days, they're working with JavaScript primarily for their front-end development. So the day, I think, of server-side rendered HTML is pretty much in the past. And now we are seeing server-side rendered React and Angular and things like that. But I'm not seeing any indication from Microsoft that they're planning on reinvesting in web forms like technology all that soon. Blazor. I was going to mention Blazor. So there is one glimmer on the horizon for that. That's an exception, and that's Blazor. How many of you know what Blazor is? A bunch of you, awesome. All right, so Blazor recently just shipped 0.2, and it's spelled B-L-A-Z-O-R, and it's basically a way that you can compile .NET into JavaScript. So some time ago, like 10 or 15 years ago, Scott Hanselman made the comment on his blog that JavaScript was like the assembly language for the web, and he was right, because now we're like compiling all kinds of things into JavaScript and running it on any browser. Just as JavaScript. So you can take your actual C# or whatever, VB.NET, .NET assemblies, compile them, and ship those DLLs down to the browser, which will then execute that code cross-platform, by basically running it as JavaScript. It's still really early days, so it'll probably be some time before we see like that being production ready. But it does give some hope that there might be a renaissance in component markets that aren't just free JavaScript components. In the early days of .NET, there were a lot of different component vendors out there that were able to sell, grids and charts and other things, and a very vibrant community. And lately, companies that's their business model, like Telerik and DevExpress and Infragistics and those folks, they're finding a smaller and smaller customer base because everything's moving to JavaScript, and JavaScript's pretty much all free and open source. So perhaps with Blazor, we'll see a way for those companies to compete once again and sell those types of products. All right, so about half to 2/3 of you are using .NET Core. What is anyone else using? If you're not using Core, are you .NET developers primarily, or not? Okay, who's not? Who's here that's like Java, Python, anything else? One person? All right, two. All right, cool. Well, hopefully this is worthwhile for you as well. I'm not going to spend a ton of time on ASP.NET Core until the end. I'm going to step through a full sample project. The rest of the time, we're pretty much going to talk about principles and dependencies and how to write software that doesn't fall over under its own weight because it's too tightly coupled together. All right, so a couple resources that you can look for more information. I have a few courses out on Pluralsight. I'm guessing most of you have heard of Pluralsight by now. You may not have heard that they're actually going to have an IPO soon. So probably next month, they're going to go public. So that'll be cool. We'll see what that does to the company. I've got about 10 courses out there. There's a couple that are related to this talk, specifically the one I have on interior applications and another one on domain-driven design. Weird being up here on the stage. The screen's like below me. I also have a course on DevIQ, which is a startup that's kind of similar to Pluralsight, and it's on ASP.NET Core. So if you're interested in learning more about ASP.NET Core, you can get that there. And I have cards up here that are good for a discount on that if you want them. I have a book I wrote for Microsoft. So it's an ebook. It's free. You can download it from the URL that's shown up here, or just do a search for eShop on web, because that's the name of the sample. There's a full sample on GitHub, and it follows pretty much clean architecture. So if you want to see a working example of these principles, that's a good place to look. The book's like 150 pages and talks about how to build these types of applications with .NET Core. And there's a couple chapters on Azure, but it's not so much a commercial for Azure except the last couple chapters. And then if any of you have teams or projects that would benefit from my assistance, please feel free to reach out to me. That's what I do. So without further ado, let's talk about questions that we will answer in the course of this presentation. So do any of you have questions before I get started? I've been told I can give away some swag here if you do, about what I'm going to be talking about tonight. Anything you want to make sure that I cover, just in case I don't? All right, well, guess what? I have questions. That's why I put these here. So because I'm familiar with audiences that never want to talk back to me, I fed this up with some questions here. So the first question that we will answer tonight is, why do we bother to separate our applications out into multiple different projects, typically in a solution in Visual Studio? A similar question is, what are some of the principles we can apply to organize the modules of our software, which is typically in .NET, it's going to correspond one-to-one with those projects. And what effect does that have on the coupling in our application, in our solution? Decisions that we make on which places we decide to put the code, which modules we break it up into, which project, and then how those projects interrelate, how those project references are set up, will have a direct impact on the coupling in your application. And if you get that wrong on day one, when you first say file new project, it can have a dramatic impact on how easy it is later on down the line for you to do stuff like write unit tests for your code. What are some of the problems that you get when you follow certain common approaches, like doing it the wrong way and then everything's tightly coupled? We'll talk about them, but spoiler alert, they're really hard to test and can be hard to maintain. And then how does clean architecture address these different problems? So all this and how ASP.NET Core can help will be coming soon, like right now. All right, so before we get started on the actual concrete patterns and what the architecture looks like, let's talk about some underlying principles that we can use in general when we're talking about software that hopefully we can all agree on. And if you have questions or disagree, feel free to raise your hand. So first, we have separation of concerns. How many of you ever got one of the calendars that Nimble Pros and Telerik and other companies I had did? They had these. Yeah, okay, so this is one of the pictures from one of the software craftsmanship calendars we put out a few years ago. I guess this was from one of Telerik because that's down there in the corner. And the idea here is, when you're writing your software, you don't want to let your plumbing concerns be sitting in the same space as your business logic or your user interface concerns or other things like that. So in this particular image you see we've got our Drano and our plunger sitting right there with our meat and our pipe wrench, which is probably not what your refrigerator looks like, although this was taken in the office at Teller. You might have been staged for the picture, but I can't be sure. So separation of concerns tells us that we want to avoid mixing code that has different responsibilities inside of the same method or the same class or even the same project, if we can help it, inside our application. And when we follow this principle, it gives us a number of benefits. Now, the big three that we want to look out for and make sure that we're separating are, of course, going to be the data access, the business rules, or if you're following domain-driven design, the domain model, and then, of course, your UI. And you might have multiple UIs. In fact, most web applications that you're writing these days will often have potentially a user interface that's just rendered if you're not doing just a SPA application. And you might also separately have an API that you expose that your mobile apps or your front-end JavaScript apps can use. You can think about your public-facing API and your actual application as being two different user interfaces. And so you don't want to put business logic or data access logic inside of either one of those user interfaces, because then you'll have to duplicate it into the other one, or they'll evolve separately and you'll have an inconsistent application. All right, so there's one mistake I made in my slides. Cool. All right. So now the second principle that I want to talk about is the single responsibility principle. And the single responsibility principle is the S in the solid principles, if you've heard of those. And it says that you should have only one reason for a class or a module to need to change. And what that specifically means is that you have different stakeholders potentially, or different end users that are interested in the behavior of your application. And you don't want any change in one of those stakeholders' requirements to break an application or force a change in your class that would affect another one. So let's say that you've got a financial application that does reporting, and you've got some requirements on the format of the report. Needs to be in a PDF, and it needs to be formatted a certain way. And then you have your generally accepted accounting principles that specify how the numbers need to be calculated. And if you put both those things into one report class, then if either the principles change for accounting or the requirements for how you're going to render this file, then you're going to have to change that class. And there's a possibility when you do that you're going to break the other one. Right? And this just gets worse as you add additional responsibilities. So you want to make sure in any given class that you have that it only has one reason to change. It only has one thing it's doing that if some requirement changes, that this class would need to change because of just one requirement. So this works in tandem with separation of concerns. If you're following separation of concerns very, very explicitly and down to a granular level, your classes are only going to have one responsibility and therefore one reason to change. Now, one thing that people get tripped up on sometimes when we talk about single responsibility is, I have a class and it's the customer manager, and it's only responsible for customers. And it gets them from the database and it formats them and it reports on them and it has all the rules for their pay raises and it does everything about their, HR principles. That fact that it's responsible for customers does not mean it only has one responsibility. Okay, so make sure that you're keeping it very focused on anything that would change from a requirements perspective. There's only one thing that would cause that class to change. Any questions? All right. The next principle we're going to talk about is the don't repeat yourself principle, or the dry principle. Again, this is from those calendars. We actually put it in like just about every calendar. We've repeated it. And so repetition is really one of the roots of all evil in software. That's one of the reasons why we have a lot of the abstractions we do and a lot of design patterns. They're designed to make it so that we can put logic in one and only one place, so that when we need to change it, we can go to that one place and make the update, and it affects everything the same way, rather than having it copy-pasted throughout our application. And then when a change comes in, we go and we change it in 3 of those places, we forget the 4th one, and boom, now you've got a bug in your system. So when we follow the don't repeat yourself principle, we're typically going to take repetitive code that we see the same pattern happening again and again. And one of the first refactorings we might do is pull that out into a function. And then we want to take those functions, group them into cohesive classes. So when we say cohesive, we mean the things inside that class all relate to one another. You don't have like 3 methods in a class that work on its internal properties or fields, and then you have this last method that doesn't work on any of the state of that class and just does something else as a utility. Right? That's not cohesive. It doesn't really belong with those other things. So we want to make sure the classes are cohesive in addition to having only one responsibility. Really, if you follow the single responsibility principle, your classes are going to be cohesive because they're only going to do one thing. So those two kind of go together. And then we have ways that we group our code, and this is leading up into the architectural discussion. So at the low level, we have lines of code, and we take the lines of code, we group them into functions. We group those up into classes that are kind of containers of functions, which are containers of statements. And then we group the classes up further into folders and namespaces, and eventually into projects, and probably into a solution. Now, each step along the way, this is helping us to kind of organize things in some way that helps us and our team members find things and figure out where stuff belongs inside the code. And we can use the principles like separation of concerns to figure out where does it make sense to group these. Does it make sense to have a bunch of projects that are organized alphabetically, and so all the classes and things that start with A go in one project and all the ones that start with B go in another? Or does it make more sense to do something like sort them out by data access versus business logic, et cetera? Generally, in larger applications, there are some big jumps here when we talk about how much stuff is going into one of these groupings. And we don't, most of us, I don't think, spend a lot of time thinking about this. So when we talk about a statement or a line of code, that's pretty obviously pretty granular. It's about as small as we can get in our code. When we talk about a function, how many lines of code should go in a function? What's a good upper limit? Anyone? 10 lines of code. Anyone else? 10's good. 10 sounds good to me. Something like that, right? At least you shouldn't have to scroll on your program to see it, and it doesn't mean go down to a 6-point font on a 1200 screen. So let's say we could put 10 statements in a function, and we all agree that that seems reasonable. All right. Then how many functions might go into a class? As many as go together? Well, okay. Well, what if you looked at a class and you saw that, let's say functions are 10 lines of code, and you looked at a class and it had some amount of lines of code, where is the lines of code for the class going to be that makes you think, ooh, this is getting a little ugly? And you can kind of backpedal from that into how many functions that works out.
20 functions.
20 functions? Okay, so let's go with that. So we got 10 lines of code in a function, 20 functions in a class. Then we go up to folders and projects. How many classes go in a project? Is there an upper limit in anything you've ever worked on? Like, usually no. It's like, okay, everything goes in there. Maybe we'll put folders. And maybe once the folder gets to the point where it starts scrolling inside the Solution Explorer, we'll put more folders. But that's where the hierarchies can start to break down. So there's a few other patterns that aren't used as commonly that we can apply to intermediate parts inside this hierarchy that will help us keep things more granular and give us other points at which we can separate things and group them. So the 3 grouping options that I'm not going to spend a lot of time on talking about tonight, but I encourage you to research, are aggregates, features, by which I mean feature folders or feature slices, and then bounded context, which are domain-driven design concepts. So what an aggregate is a group of entities or classes or business objects that change together. And so in many applications that are using standard data access abstractions like repositories, you'll have a whole bunch of business objects or entities, and then you'll have a whole bunch of repositories, and there's a one-to-one correspondence, right? You've got a customer and an order and a product as entities, and then over here you've got a customer repository, an order repository, a product repository. But you might have some things that only belong together. Like maybe you have an order, and the order has a list of items that belong in that order. It doesn't make any sense for you to be able to fetch and work with items from the order independent of the order itself. Right? At an object-oriented programming level, the order should be responsible for all of its internal state, which includes all those line items. Because maybe it has business rules on what those line items should be, or how it calculates tax, or whatever it might be. So what an aggregate is a pattern where you say, you can't get to the children of this collection of entities. You can only get to the root. If you need to modify any of the children, if you need to get to an order item under an order, you have to load the order from the repository, and then navigate through its hierarchy to go get to an order item, make whatever update. The order is there now, it's involved. It can run any business rules that it needs to run. And then when you go to persist it, you don't just save the order item, you save the order, and it will save its entire state in whatever valid state it is. So aggregates provide you a grouping at the business object level that you don't necessarily otherwise have if you just have a folder somewhere that says business objects, and it's got everything in there. Feature folders are another way you can organize things. So within a large web application, let's say, and you can use this in WPF or other apps as well. Instead of having just a top-level folder for like controllers, and then anything that's a controller goes in there, or pages, or whatever it might be, you can organize things using areas or feature folders, which you can get as a NuGet package, and put in specific features of your application in each of their own folders. Now, within a feature folder, instead of having well, back up for a second. A standard MVC or ASP.NET Core application, typically, you say file new projects, you've got either a pages folder, and Razor pages are pretty nice. How many of you are using Razor pages? Two. Yeah, almost nobody's adopting them. I see the hand over there. Razor pages are really nice because they have this built in, right? So they have this feature folder organizational concept built in. But if you don't have that, and you're using standard MVC, you probably have a folder called controllers, you probably have a folder called views, and maybe you've got a folder called models or view models, or even both. And they're all top level in your web project. And if you open up any one of those, it's just this huge mess of unrelated things, typically, right? And then you need to go add a feature, right? You've got this new thing you need to do, it doesn't relate to anything else, so you need a new controller for that. So you say, okay, I'm gonna create a new controller, and you go into the controllers folder and you do that. And you say, okay, well, it needs an action method, so I add that. The action's gonna have to return a view, so I get out of the controllers folder, dig down into the views folder, navigate through the dozens of different view folders there that correspond to those controllers, and finally create a new folder and add a view, and then realize, oh shoot, now I need a view model. Well, let me get out of this folder, go find another folder for view models. It's got dozens of things in it. Let me go find the right place, add that. It gets to be tedious. With feature folders, you just put all those things in one folder. So if I'm gonna add a new report, let's say, for customers, I'll have a customer report controller inside of the customer report feature folder. And then also in there, I'll have the customer report view model, and I'll have the view, and it'll all be together. So when I'm working on that one thing, it's organized accordingly. It really doesn't make any sense to organize things by controllers and views and models. If you think about it, if you look at your file system or your desktop or your documents folder, you probably don't have it totally organized by, okay, here is every PNG file, here is every GIF file, here is every JPEG in each of their own folder, right? You've got all your Word docs in one place and your PowerPoints in another and your Excels in another. You don't want to organize them by project or like personal and work. No, you just do it by file type, right? No, that doesn't make any sense. So don't do that with your projects either. And that's where these feature folders work. And if you use Razor pages, again, it has that built in. So with Razor pages, you don't have separate actions and controllers. Those are all built into the Razor page, as is the view model. So you get the architectural benefits of MVC, but you get the organizational benefits of this feature folder. And then the last one here is bounded context. Bounded context refer to taking a bunch of things that are related to each other for an application. Usually, a bounded context, in my experience, maps to a separate application, a separate thing you're going to deploy. But it doesn't have to. In a very large application, you might have several bounded contexts within it. But a bounded context lets you specify that within this context, within these bounds, these things are going to apply. I'm going to have this language I'm going to use. I'm going to model things a certain way. I'm going to make certain technical decisions and things I'm going to choose to do. And outside of that bounded context, things are only going to be able to interact with this code through an interface that I expose. Right? So you think of bounded context as the same as like an object-oriented programming, where you have encapsulation, you have private stuff that other people shouldn't be able to get to, and public things that you expose as the interface you want them to work with. But it's at the application level, or at least at the module level. And so a bounded context would have, for instance, its own database that nothing else can touch, ideally, so that it can be in control of its own state, just like a class can be in charge of its own internal state. So I encourage you to check those things out. Bounded contexts and aggregates are both DDD related, so if you read some of the DDD books or watch my DDD course on Pluralsight, you'll learn more about those things there. Any questions before I move on from these, which I said I wasn't going to talk about much?
The feature stuff sounds a lot like how you organize Angular code.
Yes, it certainly is. Yes, so if you've done Angular code, it tends to organize stuff by feature. It still might have like folders and things like services and things like that at the global level, but within any given feature folder in an Angular app, you know, the service that relates to that feature is in that folder. It doesn't just get dumped into the services folder at the root, typically, in my experience. I'm sure you could do it that way, but why? All right, so hey, you get a water bottle.
Thank you, sir.
All right, now we're down to one more water bottle. Big money. Okay, let's move on to dependency inversion. In this picture here, it says down below, would you solder a lamp directly to the electrical wiring in a wall? And which is what they're trying to do here in this picture. You see the lamp is on, so obviously this picture was not photoshopped at all. This is live. We're risking our lives to make this picture. What you want to do in your application is not hardwire everything together, right? You want to be able to swap things out later on. You want to have this notion of interfaces where you can plug and play different things into your application, whether that's a controller or a service or what have you. And interesting enough, in the real world, we have this notion of an interface. We have this adapter plug interface here that we can literally plug and play any type of appliance or electronics into because it conforms to that spec. And unfortunately, it doesn't work all over the world. But if you do travel a lot and go to other places that have different types of plugs, you can use an adapter and have a separate talk on design patterns where we talk about things like the adapter pattern that is exactly like that. So with dependency inversion, the idea here is that we're going to invert the dependency in our code on how the control flow takes place. So that at compile time, we're going to have a set of references that we're going to build against, the compiler is going to use, but at runtime, it's not going to run through that same path. So the first thing with dependency inversion that people think about if they've been writing code that uses dependency injection is how they're related. So, and they are. So you want to invert dependencies, you have to invert dependencies before you can inject them, right? So dependency injection, the practice, I don't know, I think it's a practice. The thing you do with dependency injection is allowed by or enabled by the principle of dependency inversion. And so what the dependency inversion principle says is that your high-level classes shouldn't depend on your low-level classes. They should go the other way around. And also, both your high-level classes and your implementation detail classes, your low-level implementation details, should depend on abstractions. And when we're talking about .NET and C# or VB.NET, when we say abstractions, we generally mean interfaces, although occasionally they can be abstract base classes. Your classes, furthermore, should follow the explicit dependencies principle. How many of you know what this is? One of you. All right, cool. I made this up, so like if one of you heard of it, that's awesome. All right, so the explicit dependencies principle says that your classes should request all of their dependencies through their constructor, and they shouldn't have hidden dependencies. So you want to make your types honest, not deceptive. So what do I mean by that? If a new programmer or future you that's forgotten something comes into your code base and says, hey, I need to do X, and they scan the list of files and they find a class that says it does X, and they look at the constructor and it doesn't take anything. Maybe they don't even open the file. Maybe they just use IntelliSense and say, I need to do up one of these things. Oh, look, it doesn't need anything. It's constructor. You wire it up, call the method, everything seems to build. They go to run it, and at runtime it blows up and it says, oh, invalid whatever exception. I couldn't find this file, or I couldn't find this key in the config system, or whatever it might be, right? But you had this constructor that said it didn't need anything. So it's lying to you by saying that you can just view me up. I don't have anything I need. And you won't find out that that's a problem until runtime. And it's very frustrating, and it makes it much more difficult to work with your code base. If you follow this principle, your code that would have required a file or would have required a config or whatever it might be would have taken that in its constructor. It would have had an iFile accessor service or whatever as a dependency it would use. If it needs a database, it would have had a repository or a DB connection or something passed into its constructor that would have given you a clue as the developer that, oh, this thing's going to need data access. This thing's going to need file access. Whatever it might be, it'll come in that way through the constructor. All right, a corollary to the things that we just talked about are the abstractions and interfaces that we're going to define they have to be specified somewhere that is accessible by your low-level implementation services, because they need to implement those interfaces, as well as your high-level business services, because they're going to implement those interfaces as well. Right? Remember, our high-level and our low-level types should depend on abstractions, not one another. And then, of course, our user interface entry points typically need to have access to those interfaces, because at runtime, they have to wire up those interfaces to the real implementations. So when you do dependency injection, you have some IOC container or whatever. Typically, when your app starts up, that's where you're going to wire all that up. And you're going to say, okay, whenever something asks for an I whatever, I'm going to use this particular concrete implementation of that interface for this run of the application. And the really nice thing about wiring everything up like that is that you can change it around anytime you want. So from one run to the next, you can plug and play and swap out how your application runs and which dependencies it's using from one run to the next.
Or testing.
Or for testing, yes, exactly. All right. Another thing you want to do, yes, sir?
Does that mean that if you have a class which you implemented and you're changing it, and you have a new dependency you want to use in that class, that all the invokers of the constructor have to change?
Yes. Well, potentially. Right. Let's think about that. How could we make that change without having to change anything that's already invoking?
Well, if the dependency is really only of interest to the class itself, then why would callers to that class?
Okay, fair enough. So the question is, like, why would I bother to expose it if no one else should ever have to worry about it? It's my internal, needs for this class. And then the secondary question is, well, if I do start exposing these things, and then I want to change how I design my class, I'm going to have to change my constructor, and then things are going to break all over the place. And it's going to be a pain. All right, so let me address both of those. The first one is, why should anything care about this dependency? Well, it's only really a dependency anyone cares about if it has some side effect that touches the real world or touches low-level implementation. So if that class writes to a file, if that class talks to a database, and now you want to write a test for it, and the only way you can get that test to pass is if you have a file that matches what it needs, or you have a database connection that's there and set up, it's going to make it really more difficult to test. And if that thing is difficult to test because you can't swap out that dependency, then now any other code that calls it is more difficult to test. And it just becomes this huge chain of responsibility, essentially, where everything that depends on this transitively is going to be more difficult to test. So even though nothing else at runtime in your application might care about that dependency, assuming you're writing tests, or assuming you think that you ever might one day want to write tests, you want those tests to be able to change it. And so now you have some use case that's valid where you might want to swap out that dependency. The other question is, how can we make it so that when we do change those things, we limit the impact that has on our application? And there's two things you can do about that. First, if you've written a whole application using the dependency inversion principle and dependency injection and IOC containers and things like that, you're not going to be newing that code up virtually anywhere, right? So in some tests, you'll probably have some places where you're newing up that object in order to test it. And ideally, if you're writing your tests effectively, you've got like one place where you've got a constructor for that object. And if you change it and you say, I need to add another dependency or two, you've got one test that was newing that thing up that you need to update. Everywhere else in your code, in your real code, you've got some service that needs a file and does some other things, and that service now needs an iFile accessor. And so you add that. All the other code that needs that service was already asking for it as a dependency also. Right? So you don't ever actually new it up yourself in this type of design. You're just always saying, I need this all the way up to 3. So the entry point for your application is going to be, usually if it's a web app, it's going to be a controller or a razor page or whatever it might be. It's going to have constructor dependencies that are going to say, I need an I whatever service. And it doesn't do it up. And you don't do it up. And if you search your whole code base, you won't find the new keyword for that thing in that project. But when you hit F5 and you run it, ASP.NET will new it up for you. And they will populate it in with all the dependencies it requires. And if you change what the constructor needs, it doesn't break anything in that scenario. Because ASP.NET will just, as long as it knows what those types are that you're asking for, it'll still populate them at runtime. Does that make sense? Okay. All right. Now, if you sorry to be long-winded on this, but one last case. Let's say you didn't write your application that way, and you've got a legacy application or whatever it might be, where you've got an application that already runs great, people are using it today, it's using a new keyword 100 different places to new up this service, and oh my gosh, I want to follow this principle. How can I make this work? Well, your constructors can have overloads, and your constructors can chain. So you can expose an interface through your constructor that says, okay, I want to take this dependency, I want to use the explicit dependencies principle. So I was just doing this thing up inside a method somewhere deep in the bowels of this class. Instead, I'm going to say, okay, I need this interface, and I'm going to call that interface here in this method. And I'm going to take the interface into the constructor, set it to a field, call that field from anywhere else, right? So now I've broken my object because I gave it a constructor with one parameter, and that makes it in C#, so it no longer has a parameterless constructor, and you can't do it up without that dependency. So everything breaks. But I can still now go in and say, okay, well, let me give it a parameterless constructor and have that chain to the existing constructor and pass in that new instance, right? So maybe inside this code, I might have newed that thing up 5 different places, or maybe only once. I've now made it so the only place I'm doing it up is inside that chained default constructor, which is not ideal, but it's a step in the right direction. And so it's not perfect, but it does make it so nothing else needs to change. All the things that called this newed up without any parameters still work, but anything that you write going forward where you do want to pass in that dependency, you can do that now too. So you have both cases now available. Does that make sense? Cool. That earns you a water bottle. I got no shovels at home. You can gift it to somebody. All right, I'll leave it over here. All right. Any other questions? Yes, sir.
Specifically with ASP.NET Core, have you been using the provided IOC container? And if not, are you using a IOC package that you're using in full framework? And if so, how do you feel about the non-conforming container or the conforming container architecture of ASP.NET Core?
The first question is, do I use the IOC container in ASP.NET Core? And the answer is it depends. But typically, yes, I start out using that. And then the second question is, do I use an IOC container that I might have previously used in full framework.NET? And the answer is yes. And typically, that's structure map. Although going forward, I would probably switch from structure map because Jeremy Miller, who's been maintaining it for over 10 years, has recently stopped doing that. So unless someone else takes it over, there's nothing wrong with it, but you know, it's kind of at a dead end from project-wise. So I wouldn't personally probably want to start new projects with it, even though I love it and it works great. So I would use something else like AutoFac or something else that's available now if I needed another IOC container. Now, why would you need a different IOC container than the one that ships? Well, Microsoft intentionally didn't want to compete with the 3,000 different IOC containers that are out there in the .NET space. And so they implemented one that was very limited in its feature set. It just did the basic things that they needed. And they didn't even give it a name, right? It's just, you know, the service collection inside of ASP.NET Core. You know, they specifically didn't give it a name because they didn't want it to be its own product or its own thing that was separate from all these other, you know, real containers. But it doesn't have a lot of features. Like it doesn't have certain things like conventions that I like to use. So one of the features I really use all the time in structure map is I can say, all right, use default conventions. And with that one line of code in my startup, structure map will now automatically wire up any types that I have where I follow the convention of I-foo, and I implement that with a class called foo. Right? So if I have an iCustomer repository and I implement that with a customer repository, structure map automatically finds those and wires them up, and I don't have to add a registration for it. So it saves you a lot of tedious, you know, updating of your dependencies inside that code. Other containers have similar features. AutoFac has similar features. And then your last question was, how do I deal with the fact that the containers aren't? What?
Yeah, so the limited service API of the built-in ASP.NET Core container.
Oh, the fact that I have to work through that?
Yeah, because like AutoFac, Simple Injector, Structure Map, whatever, they all have special features that make them each unique, and you like using the one because it does the one special cool thing you like.
Right.
And then,
Those features I only worry about, generally in my experience, inside of configure services in startup. Right. So in startup, for those of you that know ASP.NET Core, you may not realize that the startup class has this configure services method that I'm sure you've used that normally returns void. If you want to use your own IOC container, you know, third-party one or whatever, you can swap that out and have it return a provider. And inside of configure services, you new up your AutoFac container, your structure map container, and inject Unity, whatever you like. And when you're all done populating it with whatever and tweaking all the configurations and adding all the conventions and stuff you want, you just return that. And now from that point forward, .NET Core is going to use that container for all of its IOC container needs. Right? Anytime it needs a type, it's going to go ask that instance for it, rather than using its own built-in. So I haven't had an actual scenario where that wasn't enough for me. If you have one that you've run into where like you really want to use this feature of this container and you can't, I'd be interested to talk about it, but I haven't run into that myself. All right. So another principle that we want to have here that we'd like to follow is you want to make the right thing easy and the wrong thing hard. This is just general good practice for when you're designing things, whether it's user interfaces, whether it's the architecture for your solution. You want to make it so that your users or your developers can fall into the pit of success, right? You want to make it so doing the right thing is easy. So some things you can do toward this to make it so that you're not going to tightly couple everything to low-level concerns involve organizing your code in a certain way and organizing your project dependencies in certain ways. So first of all, your UI classes. They shouldn't depend directly on your infrastructure classes. When I say infrastructure, I mean things that talk to stuff outside of your application. So it's talking to web services or databases or file systems or whatever it might be. If it's sending emails or anything like that, it's an infrastructure class. It shouldn't be something that your controllers or your services that are in your UI project know about and talk to directly. They shouldn't be newing them up, and they shouldn't be calling static methods that use them. So how can we structure our solution to help enforce this rule, this guideline, that we don't want the UI to directly depend on that infrastructure? We'll see that in a minute. Likewise, and hopefully, obviously, we don't want our business and domain classes to depend on those infrastructure things either. The reason is we want to make it so that our business logic is the easiest thing in the world for us to unit test. And if we eliminate all the dependencies on infrastructure, it makes it really easy to test stuff. If you were brand new to unit testing and I said, here, I need you to unit test this class, and I haven't written the class yet, here, you write it. You're going to write a class that you can test, right? You're not going to give it a bunch of dependencies and say, oh, well, I can only test this thing if it has an active connection to this database. No, you're going to make it so that you can write that test for that. Your business and domain classes are going to be the same way. You're going to write those classes so they don't have any dependencies, because that's where all the value is in your application. It's not in all the plumbing code and how you're wiring it to the repository or how you're painting HTML on the screen typically. It's generally in the business logic of how your code does things, how it automates someone's work and makes it easier for them to be more productive, whatever it might be. So you want that to be testable. It's also generally where the most complexity lies in your code. Once you figure out how to make a particular page look a certain way, there is a lot of thought and skill that goes into that. But in an application, we generally use templates to make it so that the whole page looks a certain way, and we don't have to test that again and again and again. Whereas in each different entity or business object or service in your core, there might be really complex business rules in there that aren't the same as the business rules in the other services, the other entities that live there. And so you definitely need to have the ability to write tests for that code if you want to have confidence that it's working correctly. All right, the other thing you want to avoid and be careful of, and this follows the don't repeat yourself principle, is repetition. And so this repetition might be things like your query logic or validation logic, policies, error handling, really anything. If you've got repetition in your code, think about ways that we can apply different patterns to make getting rid of that repetition easier. And ideally make it so it's easier to follow the pattern than to just copy paste the code. Who's ever done that? All right. So now let's talk a little bit about different types of architectures. And the first one we're going to talk about is this classic n-tier architecture, where you have this layer depends on that layer, depends on the other layer. And really, all architectures that have more than one layer look like this, right? It's just a matter of how you draw the pictures. But when I say classic n-tier architecture, I really mean like this diagram here, which is from 2001 on MSDN, where they have this classical, which means ASP, where everything is inside of your ASP page, and you've got your HTML, and you've got your ADO, ADO.NET. This is old. And it's talking with record sets to a data source, like Access, maybe, or if you were lucky, SQL Server. And so you didn't have any separation of concerns, and everything was all together. And we move over here to this n-tier model, and you got your UI layer is now separated from your business layer, this workflow layer that no one uses. And then you get this data access layer that talks to the database. And this is great. And my very first conference talk was on n-tier architecture, and I talked about how great this was. Right now I'm telling you, don't do it like this. But seriously, this was better than this no structure at all version. There were a bunch of benefits. There were benefits like we could reuse our code, we could segment our team and have specialization. We could have folks who were really good at writing that data access code. Or we could have folks that really understood the business and could write the business logic and have that be a separate team or a separate individual. Made things easier to maintain, largely because of these first two items. And you had slightly looser coupling. It was possible for you to swap out the data access layer with a different data access layer. It was really hard because you had to swap out the whole thing, and you had to make sure it had binary compatibility with what you had before. But you could do it, whereas before you didn't really have any good option for doing it other than just rewriting most of the app. Some of the drawbacks were transitive dependencies, which we'll talk about in a second. You have maybe some additional complexity, and generally you still had tight coupling. Now, why did you still have tight coupling? Well, the issue here is that you've got this UI layer that depends on, as a project reference to the business layer, which has a reference to the data access layer, which talks directly to the database through SQL connection or ADO.NET. And so you can see the data access layer depends on the database, which means the business logic layer does too, and so does the UI layer. So everything depends on the database when you follow this design. How many of you are working on systems that are built like this today? Very many? It's really common. Yeah, so most of you, okay. Most of the time I see most hands go up. It's really hard to do dependency injection when your app is structured like this, right? Because the dependencies are not inverted. The dependency from the UI layer to the business logic layer typically is because you've got a controller somewhere that's newing up a business object to do stuff with it. And then inside that business object, it's either inheriting from a data access layer, or it's newing one up, or it's calling some static data access method to do the data access work. And then that data access layer, of course, is going to talk straight to the DB. So you don't have any option to break things apart. There's usually not a lot of interfaces or abstractions here. So everything ends up depending on the database, which makes it really hard to test. I've written tests where I was trying to do TDD, or I was trying to get good test coverage, and everything depended on the database because I didn't know any better. And you end up writing this database script that basically wipes the database clean, and it injects all the data that you need for each test, and you run one test, and then you wipe the database clean again, and you start over and you do the next thing. And over time, as you add more and more tests, and your app gets bigger and bigger, that script gets slower and slower and slower, and every time you add a new test that needs some new data that you didn't have before, you go and add it, and then half a dozen tests break somewhere because they didn't expect there to be one more row in this table than there was before. And so you're chasing that down, trying to fix it. And it just gets more and more friction until eventually you're like, this isn't worth it, I'm not gonna write these tests anymore. And then everything just falls apart. So the solution to that is don't test everything through the database. It's okay to write a few integration tests that need the database, but most of your tests should be testing just the method that you're interested in, or at most just the class, and not your entire infrastructure stack. And those are going to be unit tests that are much faster, much easier, and simpler to write. And if you're writing them right, they don't step on one another very frequently. So you should be able to keep adding them and not have them break existing ones. All right, so the alternative that we're going to talk about tonight, finally, is this clean architecture and this notion of domain-centric design, where we've got this core area with all our business logic, and we're going to have everything else outside of there depending on it. So let's talk about the domain model, or the core in this sense. These are basically your business objects, right? So it has your business logic, but your logic doesn't just live in a vacuum. This isn't a functional language. It has to be inside of some objects or some classes. So we also have this model of the problem that you're working on. And so this is what we would call the domain model in domain-driven design. And it involves things like entities, value objects, interfaces, services, maybe domain events, and some other things as well. We'll talk more about all the things that go into the core part of your application in a couple more slides. Your interfaces live inside of this domain model, and they define all the contracts for working with these domain objects. And since they live in the domain model, they only have references to domain model concepts. So you're not going to have an interface that takes in as a dependency or as a parameter, a SQL data reader, or returns back a SQL data reader for that matter, because it doesn't have any notion of entity framework or ADO.NET or whatever data access you might be using. It only knows about domain model stuff, so it might return a list of customer or an IEnumerable of customer, but it won't return a record set of customer where a record set is in some infrastructure library. Everything else in your application, all the other projects, depend on this core project in this domain model. So your infrastructure and your UI and anything else that you've got, all your tests, will depend on this either directly or transitively. All right, so when I talk about clean architecture, it actually has a few different names. If you've heard of any of these or worked with any of them, they're all basically the same thing. It's the latest name for these. So back in the day, like, I don't know, 15 or 20 years ago, someone wrote an article about ports and adapters, and it was an architectural thing that you could use. That was basically what we're going to talk about tonight. And then it got renamed, or someone else wrote an article. They referred to it as hexagonal architecture, and we'll see why in a second. Not some other shape, mind you. It had to be hexagon. And then a friend of mine about 10 years ago wrote a blog post talking about the onion architecture because it had layers. And this was, despite the fact that it came out after Shrek, he didn't call it ogre architecture. But onion architecture and then clean architecture. This is what Uncle Bob Martin has recently coined it. He has a clean architecture book that just came out last October. That's as usual good stuff. I'm a big fan of his. And it goes into some detail about some of these things as well. So let's look. This is an example of onion architecture's diagram. If we look at the very center here, really the first 3 circles are all part of what I would call your domain model and your core project. So at the very center, you've got your domain entities. These are literally your business objects. This will be your customer type, or your order type, or your product type. And then around that, you have interfaces to work with those entities. So you've got your repository interfaces that you'll use to fetch these things from persistence and store changes. And around those, you have different types of domain service interfaces. So when you have business logic that doesn't belong inside one of those entities specifically, and you want to put it somewhere inside your domain model, you put it inside of a domain service. And you have that domain service implement an interface because you don't want anything to depend directly on that service. You want it to depend on an abstraction. And then around the outside here in the purple, we've got your client UI. So this will be your ASP.NET Core project or whatever, it doesn't matter. Look, it's got SL because this is from Silverlight days back when that was we got infrastructure like repositories and things, anything that talks to database, web services, whatever, that's infrastructure. WCF services, that's when people use WCF and not REST. And then your tests and stuff are down there too. How many of you still use WCF? I'm sorry. It's okay. It's just a lot of XML.
Been around for years.
Yeah, and it works too. And it's you know,
Oh, we
you
use
configure it, it'll be faster than the REST stuff, but the web stuff's got a lot faster. Okay, so here's why at one point this was called hexagonal architecture, because someone drew this pretty picture. And this was literally the ports and adapters architecture that they were drawing a picture of. And so you see those purple things are the ports, and all these different boxes around the outside, those are adapters. So those purple things, those ports, those are interfaces. And those adapters, those are just classes that implement that interface. All right? And in the middle, they didn't want to draw another rectangle with rounded corners, so they made a hexagon. So hexagonal architecture. That's why it's called that. They could have drawn it as anything else. We could have trapezoidal architecture, whatever. But it's the same idea. It's just drawn a different way. Okay, and the general idea here is that you've got this domain layer that everything else depends on, and that exposes the interfaces that everything else uses. And that lets us get this dependency inversion, and it's what enables us to use the technique of dependency injection in our applications. It makes it so it's easy for us to swap out things. And if you remember the picture of the plug with the lamp, we can easily swap out an in-memory database for a real database. We can easily swap out whatever real services we're working with fake ones that we can use when we're testing. Whether that's a unit test or whether that's an actual full scalability test for the application where we want to mock out some part of it. Or we want to say, well, what would happen if our connection to SendGrid was suddenly much slower? We can do that by just swapping in a fake instance of SendGrid and telling it to sleep for a little while before each request. That's really easy to do with this architecture. It's really hard to do when everything is tightly coupled together. All right, so some of the rules of clean architecture. The first rule, do not talk about, that's something else. Right. The first rule is that the application core contains the domain model. Right? So all your business objects, your domain model, all that stuff lives inside the core project. And then all your other projects, they depend on the core project. I already mentioned that, but it's worth repeating, despite the don't repeat yourself. And then your inner projects, specifically and especially the core project, are where you define your interfaces. So I've seen in a lot of different code bases where you'll see a class and its interfaces like right next to it. Right, I've got this I whatever, and then right next to it is the thing that implements the interface. Sometimes they're even in the same file. Right? Here's the class, and there's the interface, they're right together. That doesn't enable you to do the dependency inversion that we're talking about, because now anything that has a reference to that interface is referencing the exact same project where the implementation lives. So the project dependencies are still pointing toward the implementation, even if you're not directly using it and you're trying to just use the interface. So in order to enable that dependency inversion, you need the interfaces, the abstractions, to live in a different project from where they're implemented, generally. And so that's why inner projects define the interfaces, outer projects implement them. Sometimes you'll have an interface and its implementation in the same project, but this should be the exception, not the rule. So when I mentioned domain services live in the core. They implement interfaces. Those interfaces are also in the core. But because they're both in the core, you're guaranteed that neither one of them depends on any infrastructure types. They only depend on your domain model. So you still have a clean domain model at the end of the day when you follow that approach. All right, avoid direct dependency on the infrastructure project except from integration tests. Notice I didn't accept anything else, right? The integration test should be the only place where you're directly depending on the infrastructure.
No
what's the question? All right. The benefits or the features of this architecture, it's framework independent, so you can use it with anything. You use it with MVC, ASP.NET, use it with Java or Python. It's not proprietary, there's no package you have to download or install. It's database independent. In fact, it really doesn't care about the database. It takes the database and just kind of pushes it off to the side and says, yeah, at some point we need to store stuff somewhere, and later on we're going to ask for it, but I don't care whether it's SQL Server or MongoDB or whatever, Oracle. You know, it's just a place to store stuff when I need it for later. And sometimes you can write a whole application without ever having a database, and then like comes time to ship, and your boss is like, "Hey, they're going to want this stuff to still be there the next day when they come to see it." You're like, "Oh, all right, well I better just point that at a database," and then you're done. So if you're used to building things where the database is the center of the universe, this is a big mind shift from other ways of building things. Now, you don't have to build everything, code first and without the database. It's just a lot easier if you do, in my opinion. But you can still certainly leverage the database where its features make sense. One place where I still use database features frequently is for reports. So, if I want to write a report, it's way easier for me to write a stored procedure or a series of views or whatever it might be to get the data sliced and diced in just the way I want, than trying to do that through C# in a domain model with enemy framework. That's just so for querying and for reports and things like that, databases, they make a lot of sense. But for your business logic, where you have all your business rules encapsulated in this application model, the database is a side concern. You just want to know that the next time you go fetch out this entity, it's going to have the state that it had before when you saved it on the previous request that the user made. It's also UI independent, so the architecture doesn't care about the UI. You could slap multiple UIs on top of this. You could have a web API, you could have a web forms, you could have a, MVC, you could have Razor pages, and any of those, it doesn't matter, it all works fine. And it is extremely testable. So when you build things using this approach, the whole thing is very easy to test, especially the core domain, because it has no dependencies. And the thing that makes testing hard is those dependencies on infrastructure. So we cut all those away, and we make it impossible, because of the way we structure this project, to add those dependencies. It makes it so that anything we put inside that core project is, by definition, easy to test. All right, so if you have an existing project and you want to refactor toward a clean architecture, there's a couple different cases where you might be starting. So in the first case, you're starting from a properly organized solution. You don't really have a whole lot of refactoring to do, so it's easiest in this case. So what that means is, if you're starting from scratch, or if you're rewriting an existing application, set it up correctly at the start, and your life will be easier, from that point forward. Next best is if you have an application that only has one project. So everything is organized maybe in folders, but it's all in one project. That gives you a lot of freedom to move stuff around, because you're not going to run into any issues with project dependencies, circular references, Visual Studio or MS Build saying, hey, I can't build this because you moved this to there. And so this is the next best. The toughest one is where you've already got an n-tier structured application where you've got the UI, depending on the business layer, depending on the data layer, and a bunch of different projects and things. And they all have existing references and dependencies that you're going to have to try and break. So this requires the most work, but you can still do it. It's easiest if you start small and you start pulling out individual little things one at a time. And usually the easiest way to go with this is to create a new project that you're going to call core, and just start pushing things into there that have no dependencies and have other things start to depend on it. And if you're not writing unit tests now and you think you should be, or you want to get into that, that project now becomes the thing that you can unit test, because it has no dependencies, so it's really easy to write tests for. As an aside, when you're working on legacy software, you're working on existing code base, anytime you've got to add a new feature or fix a bug or otherwise change the behavior of the code, the absolute best way, the safest way for you to do that is to write a new class. Or write a new method if you can't do a new class. But if you write a new class to implement that change, you're guaranteed not to break anything that's already out there, because nothing else was depending on your new class. So with that new class, you can do whatever the heck you want. Right? You're completely free from any constraints. So next time you're in some big ugly method and you're like, oh, I've got to try and fix this and it's 1,000 lines long and I don't know what to do, you can just take that code that you were going to write right there and just say, I'm just going to new up a class right here and call some method on it. And then go put that code you were going to write, put it inside that class. And now in that class, you're free to do whatever you want, right? Because there's no dependencies on it. And then you can write tests for that method, you can do whatever you want there. So you're going to keep that method from getting even bigger, for instance. So don't overlook the value of writing code inside of new classes as you're extending functionality in your application. It also helps follow a single responsibility principle. All right, so let's talk about what goes in that core project that I mentioned a few times. Again, this has no dependencies, or rather minimal dependencies. It's going to depend on the framework. It's going to depend on .NET or whatever you're writing your application on top of. It's going to have your interfaces, your abstractions. It's also going to have your entities, your value objects, aggregates, which are groups of entities and value objects. Entities are basically anything that has an ID that you're going to store and retrieve from the database. Value objects are things that don't have an ID that you can just compare based on their properties. So that might be something like date time or string or even someone's address. Typically if you've got 123 Main Street in Cleveland, Ohio, that's the same 123 Main Street if I compare it with another instance of that object. It doesn't have an ID that's associated with it. Your domain services will also live in core. These will implement these interfaces. Usually I put business level exceptions inside core. So rather than having a null reference exception or an index out of range exception or some low level .NET exception bubble all the way up to the UI for the user to see or for your logger to find, inside of here, you can instead put in something that says, hey, this product was not found, right? That's a lot better than a null reference exception where I have to go track down, well, what was null, because somehow .NET can't tell you that. So that's awesome. If you anywhere inside of your business layer you find you've got these low-level exceptions, try and wrap them in business level, at this level of abstraction exceptions instead, and make it so that from that point upward in the stack you're working with something that makes more sense in the context of your app than a low-level base exception. You can also use domain events and event handlers. I have a whole separate talk on domain events. They're a great design pattern for decoupling purposes. They're also covered in my DDD thing on Pluralsight. And specifications. How many of you use specifications? All right, cool. So specifications are another design pattern. They're in DDD as well. How many of you use repositories? All hands go up just about. All right, so repositories are super common. Quick show of hands, how many of your repositories, in addition to having their usual CRUD operations for get and list and add and update, how many of them have additional query-related methods, like get this by that and get the other with this and things like that? Yeah, okay, lots of methods. Or how many of them return iQueryable? How many of you repositories return iQueryable? A few, okay. And then everywhere else in your code, you've got where blah 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 lambda expression and query information. Now it's not in the repository. Now it's in all your controllers and services and everywhere else. The problem that you can run into with repositories, you don't immediately run into it, but over time, is that they can get bigger, they can get bloated. You can have this product repository that suddenly has 50 different ways to search for products because there's all these different scenarios. Or you return iQueryable, and now you've got 50 different places where you're doing a where clause with some custom lambda expression, and there's a lot of duplication there between those things because somebody decided it was a good idea to implement soft deletes, and so now everywhere you're listing this thing, you're also saying, oh, and enabled equals true, or whatever. And so that just becomes a hassle. What specifications are, they're a design pattern that lets you encapsulate query logic into an object. And so you would have a specification for, I don't know, enabled product with specification. And it would have inside of it the where clause that said whether or not it was enabled. Like, oh, its publication date was in the past and its enabled flag is set to true and whatever the logic might be. And then you can stack those together with other things. So you can say, well, I've got the enabled product specification, and I'm going to build on that. I'm going to stack that together with, products that shipped last quarter or whatever it might be. And you put all that inside of an object, and now you can test. And by the way, you can test it in isolation from your database. So I can just, create a test that has a list of things, populate it with a bunch of stuff, and then run some tests with the specification and validate that when I run this spec, I had this list, and now I have this list, right? My filter works. And so I can unit test these things. I can give them nice names. So inside my code, instead of saying a controller that says, hey, give me a list of products where, here's this big long lambda expression I can't read. Now it'll say, hey, give me this list of products, and I'm passing in a new instance of the featured product specification. Oh, this must be getting featured products. That's easy. And so the other thing this does is if you were using methods on your repository for that, and you had a get featured products method, that was great because it was well named, but your repository kept getting bigger and bigger and bigger. And now you're starting to not follow single responsibility principle, and it just gets to be harder to work with. You think, hey, how can I break this up? If you break it up by using specifications, you just have one list method that takes in a specification. And all the logic of how you do those different queries, they go into the specifications themselves, which can easily be tested on their own. So it's a great design pattern to check out, and it can help you with scenario of bloat in your querying logic. Yeah?
So in the case of something like Entity Framework, is that kind of just your iQueryable is encapsulated in there?
Kind of, yeah. It's not an iQueryable, it's an expression of func of t, comma bool. But it's the same thing that your where statement in link accepts. So if you look at IntelliSense, you say .where, take something, it takes in an expression of func of t, comma bool, where t is the entity.
Lend itself to a very fluent design.
Yeah, and so, and the beauty of it is that it takes in that thing that is just dependent on framework types, right? Expression and func and all those things. Those are just framework things. They're not EF things. So you can use that exact same thing in your specification. Your specification will have a property or something, which is the where clause or the criteria, I usually call it. And it'll be that type. And that type is independent from EF. So you can test it without EF. You can test it against other providers. You know, and Hibernate can be wired up to use that same expression tree syntax and generate SQL from it if you decide you don't want to use EF anymore. But yeah, it's that same type of thing. Question?
Do you have that in your DDD course on Pluralsight? Do you cover that? Or?
I don't remember, honestly. I think we might not. I think that might not be there. Oh wait, no, it's not in there, but it is in the design patterns thing on Pluralsight. So if you go to the design pattern library on Pluralsight, that's where I added it. So it's its own separate design pattern. It's a standalone 40-minute module or something inside the design patterns library on Pluralsight. Yeah.
Do you keep this pattern to more primitive query operations, or do you let it scale up to things like joins and things?
Do I keep this pattern, the use of the specification for more primitive, simple criteria, or do I let it scale up to joins and things like that? I primarily use it for the simpler ones, honestly. But I don't know whether it wouldn't scale up. I don't know that I've run into those situations where I've needed it. Usually when I start needing to do lots of joins and things like that, I'm writing a query that maybe I don't want to have go through my domain model anyway. Maybe that's where I want to step back and I'm just going to say, here, Dapper, go call this SQL and give me what I need. Because I find that's easier than trying to get EF to do the right thing. So that's probably why I haven't run into the need for that, is because as soon as I start seeing that I need to be doing joins and stuff in my queries in EF, I start thinking, well, I probably don't want to be doing this in EF, personally.
What was the name of the tool that you just mentioned? Dapper?
Dapper is it's a micro ORM, it's called. And it's like EF, but without most of the features. So what Dapper will do is you give it some SQL, and you can call a generic method like dot execute query of T, and then here's my SQL. And then it'll get that, and it'll call back, and it'll try and map whatever it gets back into T. So if T was a customer, and you said select star from customers, it'll map all that stuff into a list of customers. It gives you back a list of customers. Doesn't do tracking, doesn't track changes, doesn't do identity mapping, doesn't do lazy loading, doesn't do all the other things EF does. And consequently, it's super fast. It's actually Stack Overflow wrote it, and Stack Overflow uses it for all their data access. So I don't know if we can trust it. I don't know if it works, but I find that it's a good tool. So so I don't dislike EF. EF is great for what it does. But there's places where if you just want to write a query and you want it to be quick and you want to write the SQL yourself, you can use Dapper and it's easier. Although EF, if you've got access directly to the DB context, you can run direct SQL on it too. So, but if you need performance, Dapper will be a little faster.
So
Sometimes a lot faster.
You use it for your queries.
I use it for some queries. I don't use it for like my domain model queries. My regular repositories and everything, they just use EF. Right? If I just need to get a customer and give me a customer with ID 123,
right.
EF does that great. It'll track changes. I can make updates to the customer. I can save it. But if I want to write a report, or if I need a search tab on my application, and it's going to generate a bunch of stuff, and it's a really custom query with a bunch of joins and other stuff, I'm not going to have that go through my domain model. I'm going to have a separate, view model or DTO or something that I use called search results, and I'm going to use Dapper or just a straight call to EF to call SQL to go and fetch that and return.
Kind of CQRS.
Yeah. I don't typically use Dapper for writes. Although you certainly can, you just have to write the SQL yourself. So, but for basic CRUD, EF is great. For more complex querying or where performance is critical, Dapper is a nice tool to have in your toolbox as well. All right, any other questions? Okay, cool. So then let's talk about the other project, the infrastructure project. What goes in there? This is where you're going to have your repositories, your data access functionality, whatever that might be. If it's Entity Framework or Entity Framework Core, your DB context will live in there. How many of you use caching at data caching in your apps? A few of you. How many of you have things that are on pages that ask for the same data more than once over the course of a day, and it's the same thing, like your menus or things like that. You know, look into caching. I've got a couple great articles on cache repository pattern. It's super easy to implement. You just slap it on top of an existing repository, and it makes it so it's cached with whatever rules you want to assign to it.
And you could insert that in with an IOC container.
Exactly, yes, that's the beauty of it. So if you're using an IOC container, you just swap in the cache repository for the real one, and you see how it works, right? Maybe you run any load test against it and see what impact it has. And then you swap it back out and run the same load test. You literally had to change like not even a line of code, you know, one word in your startup.cs, and you can see what the impact has of putting that in. So it's a really nice pattern that I use all the time. Your web API clients would go in here. So what do I mean by that? If you are talking to GitHub's API, Netflix's API, SendGrid's API, whatever it might be, through a REST interface, whatever, that client code is going to live inside infrastructure because it's talking to stuff that's outside of your code. And anything that's talking outside of your process, of your application, is going to live inside infrastructure. File system access, logging adapters that talk to files or databases or what have you. Anything sending emails or SMS, Twilio, stuff like that. Anything that's talking to the system clock in a way that is, you know, changing the behavior of your application. You want to be able to test, should go in there. So if you've got an MD, let's say, that when you create it, you want to be able to persist when it was created, and you're just going to store that, right? You don't need to abstract access to the system clock for that. You just say, you know, system.datetime.now or whatever, it's fine. But if you've got some logic inside some service that says, okay, well, we're going to have to send this person a message, and if it's during regular business hours, we're going to send them an SMS text. But if it's after hours, we're going to send them an email so we don't wake them up at night or whatever. And you want to write a test for that. Your test is going to say one thing during business hours and a different thing outside of business hours. If you depend directly on datetime.now, your system clock. So if you instead, if you inject in your access to the system clock, now you can have an interface for that. And you can mock it out in your test. You write tests that say, what does it do at 12 o'clock at noon, and what does it do at 12 o'clock at midnight, and see both of those cases. And then any other services that you might need to go in. Occasionally, you're also going to have interfaces in here. Why would you have interfaces in your infrastructure project? Well, sometimes you have interfaces that you need for infrastructure services, infrastructure things, right? So maybe you're implementing Twilio or SendGrid or whatever it is, and it has in their SDK some interface that you can use or some types that you can use. Those interfaces, if they're not in a separate package, you would put inside of here because they probably refer to infrastructure-specific types, right? It returns back a SendGrid or whatever specific thing that you don't want to have the rest of your application depend on, so you put that interface inside of this project.
Just for example, wouldn't your interface for system clock be in there?
No, I would usually have the accessor because it returns back a system type, a datetime, or a datetime offset. I put like an I system clock or something, or an what do I call it? iDatetime. I usually call it iDatetime, and I put it in core. And then I have a system clock datetime or something like that that goes in here. So the implementation is here, but that interface I usually put in core. And then in some domain service, I could use an iDatetime to see what time it is. And then later, if I need to test that domain service does the right thing, I can inject in my own fake datetime that says whatever time I want. Okay? Yes?
If you're translating from your core objects to an object that one of these APIs needs, you do it in here too.
Great question. So the question is, if I need to translate between my domain model and something else, like say what I'm using for the web, or sorry, what I'm using for a web client, what I'm using for a repository, whatever it might be, does that happen in here? And the answer is yes. So your repositories, I'm not going to spend a lot of time talking about repositories, but they should all return your core domain objects. They're going to return the entities that are defined inside the core. You don't want your repositories to return a SQL data reader or a DB context or a DB set or anything that's specific to your implementation details of data access because there's supposed to be an interface, an abstraction. The interface for your repository is in core. So for this thing to implement that, there's no way that it can have any knowledge of specific implementation details of how it's doing its thing. Any other questions? Let's talk about the web project now, what goes in here. You've got your controllers, your views, if you're using MVC traditionally, or you've got Razor Pages, which is kind of wrapping them both together. Again, I encourage you to check out Razor Pages if you haven't. They're introduced in ASP.NET Core 2.0. Also, you're gonna have all these other types of models, potentially. You probably won't have all of them, but you might have view models, you might have API models, you might have binding models, you might just call them all DTOs. They're all basically the same thing. These are data objects that you're going to use to communicate outside of your application, either by binding them to a view, or by sending them over the wire as part of an API, or by accepting them into your application as a binding model using model binding, whether that's through an API or through a form post to a standard controller. And so all those types get defined here inside the web project typically. In an MVC type application, you're going to have filters if you're using those. Model binders, like custom binders, would also live here. Any kind of HTML or tag helpers would also live here. Those are all UI specific, so they belong inside the web project. And then any other services that it might require. And occasionally, and very rarely, it might also have interfaces where those interfaces are specific to web things. All right, so if you have some interface that needs to talk about a web client or an iResponse or iRequest or whatever it might be, those are going to live inside the web project. Cool. All right, any questions? All right. So then there's one more type of project that we can talk about. In domain-driven design, they call this the shared kernel. And the shared kernel is like even less coupled than the core project that we've been talking about so far. And so this is where you would put common things that need to be shared between different applications or between different solutions. So in my experience, the best way to distribute these packages is as NuGet packages. Frequently in a lot of organizations, they have these types of shared libraries that multiple different solutions, teams, projects all depend on. But they'll often put them inside of the same solution, which is great for debugging because you can just step right into the thing. But it means that anytime anybody changes anything in that, it automatically breaks all the solutions as soon as they do a get latest from source control, which is not ideal. So if you take those and instead you put them in as NuGet packages, then you can have that in an internal NuGet server, and they have versions. So you can have, you've got half a dozen applications, they all need this shared functionality. Initially, they all depend on version 1. Now one of them needs an update. You update the shared package, it goes up to version 1.01 or whatever, and that one can update. All the other apps that are still fine using 1.0 stay with 1.0 until you decide that you want to update them, and you don't end up having to break everything all at once. So what might go in shared kernel? So your base types for some of these patterns might live there. So if you've got a base entity that maybe defines your ID, or some other things that maybe you always want to have auditing, so you want to say like when was it created, who created it, when was it updated, who updated it. All that base stuff can live on that entity, and that can go in shared kernel, so all your solutions use it. Your base domain event, your base specification, same idea. Common exceptions and common interfaces that you use can go there. And frequently things that have to do with authentication and other cross-cutting concerns go there. So most organizations, they have some solution they use for authentication. They don't want users to have to come up with a new user and password for every different little app that you write. So you've got some kind of common user class and way of doing authentication. You probably are using a common dependency injection approach. Either you're using the built-in one, in which case you don't need anything here. But sometimes you'll use something that you need to depend on even at the core level. So that might be structure map, autopack, whatever it might be. You'd put that in shared kernel as well. Same thing with logging, same thing with common guard clauses. How many of you know what I mean when I say guard clauses? Cool, so I have a whole slide for that. All right, so guard clauses are a nice pattern you can use, like a little micro pattern, where basically you do some check for some common rule, you do it in a conventional way, and then you immediately throw an exception if it's not there. It's sort of like an assertion. And so you can create these very easily, and you say, they're very fluent to read typically. So you can say guard against null of this parameter here, and then name of, that's just so it can form the exception correctly and put the message correctly. The benefit of this structure, whether you're using guard clauses like with this package or you're just doing it yourself with an if statement, is that your code is a lot less complex. It's a lot easier to follow. It's not going to end up being nested with a bunch of if statements and else blocks and things like that. If you look at this, it's like either it's going to throw an exception here, or we're going to do the work, right? There's no if else. There's no difficult thing. And if there's 5 different parameters here and they all need some kind of check, you just do guard, 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 and then boom, do your happy path. So all your sad path things of your defensive coding, places where stuff could go wrong, you just put all that up front and just blow up immediately. And otherwise, if you get through all that, you've run the gauntlet, you know your code is good, at least from a simple checks of the parameters standpoint, and you can proceed on without any plumbing for if checks for that kind of validation. So this library of guard clauses has a bunch of the ones you would expect, like is null and things like that, as well as ways that you can easily implement your own. So you've got a common way of doing these types of checks inside your code. All right, so this is your solution structure when you're done. So it's the clean architecture, it's onion architecture, whatever you want to call it. And so you got your shared kernel, which is ideally a NuGet package. Then you've got your core project, which has no dependencies, except maybe on shared kernel. So you want to be super, super careful that shared kernel doesn't have anything in it that you don't want everything to depend on. So don't put stuff in there that wasn't on my list, or you're not super sure about. Then infrastructure depends on core, and web depends on core. And then you can compile this, and it works great. Anybody have any questions? Yeah.
So one concern is the infrastructure taking the dependency on the interfaces in core, and the ability then to do things with core objects that you don't really want to. So what would you think about a separate project with more of your domain model and interfaces?
Like split out interfaces into a separate thing from your domain model object? I have seen some folks do that. I haven't personally seen a lot of need for that. But I have seen some teams where they will take all of the abstractions that this thing would normally, that I would normally put in here, and put them in another project. And it would just sit probably above this.
Yeah, kind of beside it, whatever, right? But I mean, what I'm protecting and want to protect against is infrastructure, newing up something that I don't want them to in core. I want to isolate that.
That total protection would be difficult because if you're defining, let's say, repositories as interfaces, right? They're going to have to return your entities, your domain objects, right? So that means the interfaces have to know about the business objects, which means they have to live here, not here.
I put those with the interfaces.
Those objects.
So I separate that in the interfaces into another, just a class one.
Okay, I thought those are the things you want to protect and have with those entities.
No, even just calling into, like, executing domain logic down there that I don't want them to, with the...
Sure, but for me, usually that domain logic would live on those entities. So if I can get to the repositories and I can get to the entities, then I can get to the business logic. I suppose you could say that there's like super critical stuff in these domain services, and I'll put those domain services somewhere over here that this can't get to, and that would be valid, and that would be fine. But if you're trying to split out all of the domain layer from being accessible from the infrastructure, the interfaces would have to know about some of those core objects, and any ones that they knew about, this one would be able to get to transitively. So you'd be limited in how much you could do that. Usually I have the opposite problem. Usually I'm trying to protect like the UI from reaching in and directly working with infrastructure, or the business logic from directly using infrastructure to go get data. And so that's why I like this approach. But you can only protect yourself from so many different things, right? All right. Any other questions? Yeah.
When you're taking a TCP approach and you have your bounded context for each of your different domains, do you have multiple core projects for that?
Yeah, usually when I have a bounded context, it's per application.
Oh, okay.
So each application would have this structure. And things that needed to be shared between them would be using the shared kernel. Or if they had like some need to communicate with one another, they'd either talk to each other directly through services, or they would have some kind of message queue, message bus, something like that where they communicate. There's something wrong with this picture that no one's asking about. Yeah.
That was your web project, get data back to the,
Well, why do you ask? Why would that be a problem?
well, I don't see a dependency between web and infrastructure.
Right, exactly, yes. So I said this will compile just fine. I didn't say it would run. You can compile this code just perfectly well, and it'll be fine. But when you go to run your web project, it's going to only know about your interfaces, and it's not going to have any implementations, and it's not going to do a whole lot. So you need some way for web to know about infrastructure. Now you have two choices here. You can either have an actual project reference in Visual Studio or what have you at the project system level from web to infrastructure, and that's usually what I do and what folks do. And everything works then, right? It'll compile, it'll build these things, it'll copy them to the bin folder, you'll hit F5 or whatever and it runs. But that means that any developer can come into the web project, go into some controller and say, oh, I'm going to new up a repository and start doing stuff. I'm going to new up my DB context and start calling it here. And so it breaks all that beautiful separation of concerns and dependency inversion and all the other stuff we're going for. So you don't have to have this here. You have to have those DLLs available in the bin project. You don't have to have the project reference at compile time. So another option is you can leave it like this, and then just ship these assemblies when you build. Have a post-build step that says, oh, copy these DLLs over here to the bin project. You can do that by hand if you want. Just go into Windows Explorer. As long as they're here in bin, at runtime, it'll be able to find them in your IOC container if you wire it up correctly, and wire everything together. So that's the trick there. If you really want to keep that protection, you want to make sure that folks on your team don't accidentally depend on things they shouldn't. You can follow that approach. And in practice, 98% of teams just add the reference because it's easier. But you could separate that out completely if you wanted to go that far. And I have a blog post that talks about how to do that. Structure map actually makes it really easy to do that, because what you do is you put all your registration stuff here for objects in web, and then you have a separate one over here in infrastructure that says what interfaces all those things wire up to. And then in your web project, you just say, go load this assembly by name, right? Go load my project.infrastructure.dll as a string. And then look in there for this registry, and then that registry has all the information of what to wire up. All right. So with this structure in place, you can write unit tests very easily for core. You can write functional tests for your web project, and you can write your integration tests for infrastructure. Now, that's not to say those are the only tests that go in those places. You could also write unit tests for any of those things. But these are the most important types of tests typically to write for each of these different project types. You want lots and lots of unit tests for core because you can, and because they're cheap, and because they're easy, and they're fast. You want integration tests of infrastructure to make sure the stuff is all wired up correctly and it actually works. And when you say, go get this from that database, it actually does. And then functional tests or UI tests on web, these are things that are going to actually run the web app and call an API and verify you get back the JSON you expect, or load a view and then look at the HTML and go find a string somewhere and verify that that string exists on that page that you expected. These are the slowest and most brittle tests that you're going to have, and so you want to have as few of them as you can get away with. You need some typically in mission critical applications at least, but you don't want to test like that some customer method down in here does the right thing with a functional test that has to go through the web and then through the repository and then off to some database and then back and then go get that customer and then call that method, right? That's overkill when you could have just written a unit test to do the same thing. So the rule that you should apply when you're trying to see if you want to test something is, can I write a unit test for this? If the answer is yes, do that. Can I test it with an integration test? If the answer is yes, do that. And if, oh my gosh, the only way I could possibly test this is with a functional test, then guess what? Do that. And if you can't do any of those things, then you're stuck with manual testing, or you just ship it and let your users test it. And we laugh, but that's what we do all the time. All right. Any other questions about this now complete diagram? All right, so this is your basic folder structure you would have if you use my starter. One thing that's annoyed me for a long time about Visual Studio is it does not have any solution templates. It has one, it has blank solution. But it doesn't say, hey, I'd like an onion architecture project or whatever. And it doesn't have an easy way for you to bake those in. There's been a few attempts at it over the years, but none of them really just have taken heart. So I have this structure as a sample you can clone on GitHub and use it as a starting point if you like. In here I have a solution folder called source. This is something I took from Microsoft's organization they use for ASP.NET Core itself. They didn't invent it, lots of other places do it too, but I'm specifically using it because ASP.NET Core is, and I found it useful in my career to kind of copy what ASP.NET team does. That served me well when I was first getting into .NET, and I decided whether or not I wanted to do VB.NET or C#. And I looked at the ASP.NET team, and I saw all their stuff was in C#, and I said, I'm gonna pick C#. And that was a good decision in hindsight. So in here's my 3 projects that are the core, infrastructure, and web. And then down here I have a separate test project, and it has the tests, and it has typically you would have separate unit tests and integration test projects. In here I just have one project with 2 folders for different types of tests. But you can, you'll obviously adjust that yourself if you choose to use this as a starting point. So the next thing I want to talk about is what goes inside your web project. I have probably about 10 more minutes of some slide stuff, and then I have code I want to show. And we usually go until 8:30. Does anybody want to take a 5-minute break for a restroom or anything, or should I just push on through? Since I'm already past the halfway point. All right, off we go. All right, so I'm not going to read this whole thing to you because you've all read it by now. I suspect. But in your controller, there's things you're going to do in a typical ASP.NET Core application, or even just ASP.NET MVC. First thing is you're going to get whatever type comes in from the request. Then you're going to do whatever work you're going to do to make sure that's valid. Hopefully you're checking model state that is valid. Then you're going to do the thing that the user came to you that they wanted you to do. And when you're done, you're going to return some kind of a response. And typically that's going to involve, again, creating some kind of DTO, view model, whatever it might be, and then sending that back with some kind of response type, whether that's a view or an OK or whatever it might be. So the do work part is the interesting part here, because that's what's going to work with the rest of your architecture. So option one, typically, is the simplest, where you just have repositories and you're working with entities. So if you have a simple CRUD or CRUD++ type of application that doesn't do a whole lot of real complex business logic, you might do something like this, where your controller or page is going to take in an iRepository of whatever, or a customer repository, whatever it might be. And it's going to call methods on that or set properties on that, and it's going to update that thing in the repository. And so that's your work, and it's good for simple stuff, great for CRUD. Generally, you want to map stuff to and from DTOs before you send stuff over the wire. You don't want to take your core domain objects and send them back as part of your API response, or you can send them back all you want. That's not as big a deal. You really don't want to accept those as input from APIs or posts or puts from, I guess it'd just be posts from web forms. Does anyone know why? Why don't you want to do that?
Very coupled, tightly coupled.
Okay, sure. So you don't want to be tightly coupled. You want to be able to change your domain model without it affecting people that have now taken a dependency on whatever types it is you're sending over the wire. That's perfect. That's good. There's another one. Overposting, sure. Let's say you've got a domain object, customer that has like 20 different properties, and when you say, hey, I want you to register, you create a new customer record, they only have to specify their company name and not much else, right? So now you've got this whole big thing that you might be passing around that you don't need. So that's good. There's a related thing to that I want to get to. Composition. I don't know what you mean by that.
Put together multiple domain into one page.
Okay, yes, you might have a page that has a bunch of different stuff on the forms that relate to different domain objects. Sure. And you don't want to have a really convoluted interface that you're accepting. You want to just have some view model that has just the things you need. That makes sense. The really nasty one that you want to watch out for is the fact that model binding is this cool feature that's been around for a while in MVC and ASP.NET Core, where whatever you say you want to get in as your parameter to an action or a page handler, let's say I've got a post method for a customer, and I use model binding, so I say, instead of saying I want a customer view model, I just say I want a customer, and that's what I'm taking in as input on this post. And so the user, when they hit that form, normally they just put in company name, Acme Incorporated, submit, and I get back my customer, and I check its name, and I save that, and I use the repository, and everything's happy, right? But model binding is magic, and it'll match anything that it sees that it thinks that they're trying to match. So if, in addition to the company name, I also have other fields on there, even if they're not on the form, the user can use postman or something similar to post back whatever they think might be there and see what sticks. So they can post in something like, the data was created, or whether or not it's active in the system, stuff like that. They could add all that stuff to that record. Model binding is going to automatically update it. And if I'm not careful in how I wrote my database update stuff, if I just said, hey, load this thing from the database, now replace it with whatever came in over the wire, now EF, go ahead and save it. EF's going to build an update statement. It's going to save all those things, whatever they were, not just the things I thought were going to change. And EF is also really smart. EF will walk the tree of navigation properties. So if company has a property called, I don't know, created by user, and that happens to be a user, and that user happens to also have some credentials like what roles they live in, then I can pass in some JSON that says, okay, here's my company JSON, and inside that, here's this created by user, which has some JSON, and inside there, it's got this roles array, which has some JSON, and inside there, it says administrators, right? Now I'm going to post my new company, and it's not just going to update the company name, it's going to update the user and put them in the admin's role. And EF will save all that for you.
So
it's all part of your model.
Form of injection.
Yeah, it's a form of injection, exactly. Long story short. So don't do that, right? Always use some separate DTO, at least for how you accept data in. You want to be very, very strict about exactly what you're accepting in. Don't just let model binding and EF change tracking do magic for you, because it'll bite you, or it could. All right. So here's what this would look like in actual code. You say, hey, I'm gonna post this stuff. I'm gonna take in this ID, I'm gonna look it up with the repository, I'm gonna do whatever with it, this is on the entity. And then I'm gonna update the thing back to the database and return OK. So this is the super simple case. This is about the longest any interaction should ever be. Anyone have longer? All right. Option 2 is you want to work with a service. And so you usually don't want to mix your abstraction levels, right? So if you've got controllers that work with repositories, that's great. Work with repositories. If you got controllers that work with application services that do bigger, higher grain things, that's great. Do that. Be careful when you start mixing them, right? It's not really wrong, but you know you're mixing abstraction levels at that point. You've got like low-level data access sitting right next to some domain service or some high-level business service that you're working with. So if you work with an application service, now we're going to take in whatever the data is that comes in the controller and do very little work and pass it to this service that's going to then do whatever with the repositories and things. So the service will have the repository dependency, not the controller at that point. And then the service just returns back whatever that model type might be. So in this case, I'm referring to this as an application service because it's going to live inside like the web project. It's going to know about view models and the DTOs that your web project is using. It'll just be something separate from your controller. So this is better for more complicated things. The application service then is responsible for mapping between your web model, your domain model, and it makes it so your controllers can stay smaller and lighter weight. If you have a controller and you start to see that it's got like 6 different repositories that it needs, a lot of times you can segment that down and say, I just need some application service, or maybe 2, and then those separate services can follow a single responsibility principle, and each one of them can have 2 or 3 repositories, and it's making it a little smaller so you don't have as many dependencies on the controller. And this would look something like this with the exact same method. Now, instead of injecting in a repository and doing the work in the controller, I just have a service I inject, call whatever method on it, and return whatever result. All right, so option 3 is that you can work with commands and some tool like Mediator, where you're going to do even less work in your controller. So you can use API model types that represent commands. For instance, I want to register a user, or I want to mark something as complete, or whatever it might be. And then you'll create an instance of a command and send it using this Mediator thing. And Mediator, it's a NuGet package. It's an open source project by Jimmy Bogard of AutoMapper fame. And you can just grab it and add it to your project. I've got a blog post that talks about how to wire it up. And it will make it so that all of your controllers, ostensibly, if you want to go that far, have only one dependency, which is Mediator. And then the thing that they do is they just issue off these commands, and then you have these separate handler instances that do the work.
Is the tool actually spelled without the O?
Yeah, it's like Flickr. It's
Okay,
it's Web 2.0. So yeah, it's Mediator.
Okay.
But then inside the code, it's actually Mediator.
Yeah, that's why.
So yeah, it's not consistent.
Okay.
I think the namespace is Mediator, and the NuGet package is Mediator with just a R. But then the types inside are Mediator. All right.
Great.
So you can do it like this now. It's doing the same exact work that the other ones were doing. I'm going to take in an integer in this case. I'm going to create a new command, which is this mark item complete command, pass in whatever state it needs, and then I just call mediator.send. So I'm not showing you the constructor for this controller, but in the other 2 cases, it either needed a repository or it needed an application service. Now it just needs an iMediator. And every controller and every action on every controller could potentially be reduced down to just needing an iMediator. Right? It's just going to delegate to some other thing. And that other thing is just a class that handles that command and just does the work. But it lives outside of your controller. So you can take this one step further if you want to have really small controllers. And you can say, I'm going to use model binding to get that command. And again, that command is just a DTO that's defining your web project, so it's not going to have those issues we were just talking about. And then I can say, mediator.send that command. Now this can either be a fire and forget, or you can have a result here that gets returned back. So this could be like var result equals mediator dot whatever. And so you can do it either way. If you need something to return back, that works too. All right. Any questions about that stuff? Yes.
Do you do validation at both the model binding level and the mediation level?
Do I do validation at the model binding level and the mediation level?
Yeah,
Like
so
in the handler for this, would I?
Yeah.
Probably not.
Just at the model.
Just the model binding, probably. I don't know. I don't know that I'm 100% consistent on that, but I think I would try and only do it in one place and then make sure I was confident that I was doing it all the time. If I wasn't sure, I might do it in both and use like guard clauses against null or something. But But I think I would err on the side of just doing it in the model binding place because it's a catch-all. And I would just use a filter typically. So if you're not using filters in your MVC or ASP.NET Core apps, they're awesome. I have an MSDN article that talks about them, and I wrote the docs on ASP.NET about them. But one that's super common, I think they're going to include it in 2.1. It's coming out probably in July or August, is the validate model attribute. Normally in code like this, where something's coming in, you should write some code here that would say, if model state is valid, do this stuff, else return, a error or whatever. And if you have a filter, you can put in this validate model filter on here, and I'll show it to you in the code in a second. And it will do that work on every method every time, so that you don't have to write that code ever again. You don't have that if check on every single action, just loading them up. So that's one that you definitely want to add to your project. There's NuGet packages that have it, but you can copy paste it. It's literally 6 lines of code, and you'll use it on every single action method, or you should be using it on every action method. You don't have to actually add that attribute to every action method, by the way. You just put it on the controller, you put it on your base controller, and it'll apply to all the things on that controller, or all the things that use that base type. All right, so I have code. Let me walk you through some code. There. Okay, so I've got this app. This is that GitHub project. I literally just did a get latest on what's out there. It has a core, it has infrastructure, it has web, and it's meant to be just a starting point, right? So it has a little bit of code in it, but it's meant for you to just to see how things are wired up and then throw it away and put your real code in there. So what does it have as boilerplate code? It has this to-do item entity. And so this is, imagine you've got a to-do list. So here's your to-do list. It's got a title, or item. This is an item on your to-do list. It has a title, description, and a property that says whether or not it's done. Now, normally, of course, I could just say that is done has a setter, and anybody can set it to whatever they want. But in this case, look, I just saw something. In this case, I'm making the is done read only. And so the only way that you can make this, oh, I can't see. Never mind. The only way that you can make this done is to go through the interface that I exposed, which is this mark completed interface. And so this, as you might expect, just says that, hey, it's done. But it also uses domain events. So it adds a domain event that says, hey, to-do item completed event, this occurred. It creates one of those and adds it to this events collection that lives on base entity. And it attaches this, which is this instance of this item, so that whatever handler of that event can access this item and do whatever it wants, right? It can send an email to somebody and say, hey, you finished your item, or whatever that might be. So that's entities. That's the only entity in here. Let me show you what it looks like when we run it, because it's really exciting. So here's the web project. By default, it doesn't have any to-do items, but I ran it once and populated. So it's got get the sample working, so that works. Review the solution, that's in progress. Run and review the tests. I haven't tried that. Hopefully they work. And so it's got both some views and also some API methods. So when I come here and I say list to-do items, load sample to-do items, that's just calling this populate method. Okay. Then it's got Swagger API docs. That's right. How many of you have used Swagger? A bunch of you. Good. Yeah, Swagger is awesome if you've never heard of it and you write APIs and you want other developers to be able to use your APIs easily and you don't want to write docs because that's annoying. Just point them at your Swagger endpoint here, and it will show them all the stuff they need to know to work with your API in a live fashion. So, for instance, here's my to-do items. I was gonna try and type it in the URL up here before I remembered I had Swagger, and I would have gotten it wrong because I haven't looked at this in a while. But instead, I can just go in here and I can expand this, and it'll show me, okay, this thing doesn't take any parameters. It's going to give me back some JSON. It's going to give me back a 200 success code if it's successful. And look over here, and try it out. All right, try it out. Execute the thing. Here's what it did with curl, which you can run in a command line on an OS that actually has curl, which is not my Windows machine. And then here's what I get back. Here's my JSON in the response body. Here's all my headers, etc. If I want to add another item, I can come in here and post and say, okay, try it out. And there's my example model. I don't need an ID because it's going to give me one of those. Title is wrap up the talk already. It's almost 8:15. and somewhere there's an actual execute button, and that's okay, good, and look, it created this thing, and it's got an ID of 4, and it's not done, because I'm not done yet. And then I can execute this again up here, and you should see, look, it shows up there. So it makes it so your APIs are super easy to work with. All right, so that's built in to this clean architecture sample. All right, so it's got events. So domain events, don't have time to really cover that pattern, but it's awesome. And so in here is that to-do item completed event. It's just a DTO. It inherits from a base domain event mostly, so that the stuff that handles events can know about this type. It has a bunch of interfaces, really not that many. There's the repository, which is generic. Doesn't know about EF or anything else, and just does, for now, just does generic CRUD stuff. You would add additional things there. You would add specifications if you wanted. This iHandle is used by domain events, so any event handler would implement this interface. I handle whatever type of domain event, like to-do item completed. And then this domain event dispatcher, this is used to actually do the plumbing of sending those events to the handlers. There's some services. There's really just this placeholder service that handles that to-do item completed event. It doesn't really do anything. And then the shared kernel is a folder in here. It shouldn't be a folder if you actually take this and start using it yourself. You should take anything in shared kernel and put it in your my company name.shared kernel project and put that in its own NuGet package, and then take a NuGet package dependency on it. For simplicity's sake, I've put it inside the core project here. And you can see it has things like my base domain event that just says when it happened, my base entity that just has my ID on it, and my list of events. That's how I'm choosing to implement domain events here. There's a few different ways you can implement it. Again, you should learn more. The ignore member attribute, I forget why I have that in there. I need it for, I need it for this value object. Value objects, you can have a base type that will inherit equatable. So if you're going to use value objects in your domain, and you don't want to do all that stuff yourself, you can inherit from this value object class here, and it does all the equality junk for you, so that if you compare two of them together, they do the right thing. So that's what's in core. And then in infrastructure, I have my app DB context, my EF repository. So I have one generic repository that'll work with any entity that follows my base entity type. So where T is of type base entity. And I can do my basic CRUD, so I get my ID, list, et cetera, et cetera. There's nothing too exciting here. But the domain events are implemented here. And so what happens is different types of domain events that you might have, some of them you want to have fired off and handle immediately before you persist your model. Others you only want to have handle or fire off after you've successfully persisted the model. For example, if I wanted to say, hey, you just checked out your cart, and I'm going to send a notification to say, hey, here's your receipt, you bought this stuff. If I have a domain event that does that, and I send you an email in that handler that says, hey, you bought this stuff, here it is. And then I say, okay, repository now, save the order. And boom, it blows up for some reason. The database was down, I had some foreign key conflict, whatever it might be. I'm in a bad state right there. Now, because the customer's got an email saying they bought stuff, and they're pretty sure they bought it. But my application has no knowledge that ever happened because the database failed. So in this example of this pattern, what I'm doing is I'm only sending those events after successful persistence. And so I'm doing that inside my AppDB context. And this is actually another pattern that Jimmy Bogard wrote about. And so this dispatcher here, it gets injected into the DB context. And then I override save changes. Right, so when you call DB context.save changes, normally it does its thing and it saves all the things it changed, and EF does its magic. So I do that first. Right, this line 23 says, okay, go do what you were going to do, entity framework. And if it's successful, then it's gonna come back here and you'll be fine. Otherwise, it's gonna blow up with an exception. It's not gonna do the rest of the stuff. And this other stuff here is just where it does the domain event wiring. So it says, okay, go find me all the events that have, or all the entities rather that have events. And then loop through all those entities and find all their events, clear them out so I don't accidentally fire them again, because someone could call update changes or save changes multiple times, and I don't want to fire the events again and again. So clear them out, and then dispatch them. And so what dispatch does is it just goes through all those events and says, okay, is there anything in the system that implements this interface, I handle whatever. If there is, call it and pass it in this event. And so it'll call each one of those, one after the other. And then, they return, and this all happens synchronously, right? So these domain events, when I say save changes does not return back to me in the method that called it until all those events have had a chance to fire. And if any of them have an exception, they'll blow up right at that point. All right, and then lastly, there's the web front end. It's got a small API controller. You'll see that it does dependency injection, which is the repository. There's nothing terribly exciting here that I can think of. It's got this validate model attribute filter. So I think I overstated it when I said it was 6 lines of code. It's if you count a lot of curly braces, it might be 6 lines of code. But it just does this, and you can add that to a controller to very easily get that behavior on all your controllers. Let me show you what startup looks like, and then we'll answer any questions. So this is a standard ASP.NET 2 type of startup, so it takes in configuration in the constructor. In here, it wires up in the framework. By default, it's using an in-memory database, but you can just use SQL Server with 1 line of code change. Swagger is in here. It's really easy to set up. You just say here, add Swagger gen, but down below in configure, we'll do another thing to add it. And then structure map. This container here, I am using structure map in here by default. So this is a structure map container. And in here, I do the stuff to wire up structure map. And so what this does, this config.scan, is saying how do I find the types that you want me to know about for this DI container, for structure map. And so I say, look in that assembly, and that other assembly. And so this assembly containing type is just a neat trick that makes it so I don't have to actually type in the assembly name anywhere. Because I can say type of startup, and I know startup is in the web project, so that's loading in the assembly of the web project. Assembly containing type base entity, well, I know that's in core, and so it's going to pull back the core assembly. And then this third one is the different one. Notice here I really am just giving it a string, right? So it's going to go look in the bin folder for an assembly that has that name, minus the .dll. And so this is where, if I wanted to, I could get rid of the project dependency, and I wouldn't actually have any knowledge about that project inside this application. Now, as it is, I can't quite get away with that because I have things like this call right here, where the default way of wiring up EF core is to use a generic, and that generic is strongly typed to the thing. And so the only way this works is if I can reference at compile time that appdb context. So it's not quite as simple as I would like, but you can finagle it so that you don't have that dependency. This with default conventions I mentioned briefly earlier, that says, hey, if I ask you for an ifoo and you have something called foo as a class, just give me that without me having to wire it up or register. I mentioned registry classes. Those are in here as to-dos. That's for structure map to do that thing I talked about. And then this is how you use structure map to wire things up. So another nice feature it has is this ability to wire up open generics. So I can say, and you can do this in the ASP.NET Core one too, it's just not as elegant. But I can say for anything that's an I repository of whatever, add type of EF repository of whatever. And now with 1 line of code, I can wire up anything, any generic entity to its repository. Another thing you might not know about startup, even if you've been doing ASP.NET Core for a while, is that if you give it a suffix on some of these things, it will use the environment name of what you're running. So if you have configure production, configure development, configure testing, it will call that one instead of the underlying. So here, when I run my tests, I set the environment to be testing, and it will call into configure testing from the host instead of calling configure. And so I call configure from here, and then I seed my data for testing inside this method. Configure, there's nothing too interesting here except this stuff here for Swagger. So Swagger, if you've never used it, it's pretty easy to wire up. You just need the NuGet package, a couple lines of code and configure, 1 line of code and configure services, and you're done. And that's pretty much it for the base solution structure. So I'm sure I went over some things quickly, and hopefully some of you have a few questions. Anyone? Yeah.
I think you said earlier that you couldn't recommend structure map for new work.
Yeah, because it's no longer maintained. So I did say that I've had this project for a couple of years now.
Okay.
I've just been updating. I haven't switched it over to something else.
But it's not missing something
No.
you want? Or?
No, it's just not maintaining. It's not going to get new features very quick. Like it was being updated really quick. Like when ASP.NET Core was in beta, even though it was like alpha, for like a year and a half. structure map was being updated frequently with it, so it's compatible. I would not expect that in the future, because, you know, as of about 3 months ago, the main contributor is moving on to work on other things. But as of now, it works fine. Yes, ma'am.
Do you typically put your API controllers in the same project as your UI
As the
controllers?
regular controllers. Depends on what's using them typically. I go back and forth. It depends on the project. I'll put them in there unless there's a good reason not to. A good reason not to would be if it's a public API and the rest of the stuff isn't public, right? So I'd split it based on that. If this project is basically just static content, like an Angular app, and it's calling these APIs, and the only thing I'm using ASP.NET Core for is APIs, then I might split it, because that's easier for me to stand up something that just serves up stuff, static content, instead of having all that stuff in the project. I guess the short answer, I'm a consultant, so my answer is always it depends. Other questions? Yeah.
How much of this is in your eShop on the web?
So eShop on web is a different project, and let me turn on my internet and I'll show it to you. Actually, no, I've got it locally. It's a similar but different project, so I didn't use the same thing, but you'll see it looks very similar. And I don't remember the last time I got latest on this, so it might be a little old. It's like October, but I haven't done many changes with it since then. I'm in the process of updating this for 2.1, but it's not done yet. And so here's what eShop on the web looks like. And Microsoft doesn't want to call it Core because they, through some crazy wisdom, decided they wanted to name ASP.NET Core and .NET Core. So they said, you know, let's call it Application Core so it's not confusing. So they'll call that project Application Core. That's one difference. It still has infrastructure. It still has web. I implemented the front end with Razor Pages in an update last fall. So in October or whatever is when I did that. So folks, if you have time and you want to see it, I can show you Razor Pages in the context of this. But otherwise, it looks very similar, right? So there's entities, there's exceptions, interfaces, services. It has specifications. So you can see like what a base specification might look like. Here's my expression of func of t comma bool. Let me show you real quick how that looks with EF. Since nobody ever heard of that before, if I have a EF repository that is my generic repository, and I take I want to get something by specification, I want to get one thing, I can say return my list using the spec, and I just take in a specification of T. And then the interesting code is down here inside this. So here's how you wire up a specification to EF. You would take in the specification of T in the list method, and then in here, you write this code to do the includes, because the other pain point with EF is, since we don't have lazy loading in EF core, which is a good thing, you have to be very specific about what it includes. And so again, this usually ends up being inside your repository. You have a bunch of different overloads of methods that say, get products with this, get products with that. You know, give me all the things with all the data I need. Your specification can say exactly what it needs as far as navigation properties and related objects. So that's what this does. It says, go grab all the includes that were specified in the spec. And then this does the same thing with strings. Because some stuff, if it's a nested thing, you can't do an expression with it. So you have to give it a string that says product dot whatever dot whatever. And then the criteria.
You're not looking forward to lazy loading in 2.1?
What's that?
You're not looking
I'm
forward
not looking forward to lazy. No, I think that's just going to allow a lot of developers to do the wrong thing easy instead of making the wrong thing hard. For web developers, right? There's a place for lazy loading, but it's not inside of a 100 millisecond web request. So that's, you know, I don't think it belongs in ASP.NET generally, right? And then so your specification criteria is just this, right? Just say .where spec.criteria, and then that's it. So there's a little bit of slightly complex code you would have to write once here inside your generic repository. Then everywhere else in your application, you just refer to these strongly named, not strongly named, I always say that, these well-named specifications. So I've got a basket with item specification. Well, that's going to get my shopping basket and all of its items, right? That's obvious. It's in the name. So anybody reading the code that uses this knows that this is going to do an include on items inside that spec. And so it makes it so you can kind of work at a higher level of abstraction than having to look low level at the plumbing of EF. All right, so that's eShop on web. It's a monolithic application, meaning it's not using microservices. It's deployed as one thing, like a traditional ASP.NET Core app. There is also a companion book and project called eShop on Containers that uses Docker containers and microservices to do the same thing. So let me run this and see if it actually runs. I don't have a lot of confidence, but we'll see. And show you what it does. The eShop on Containers does basically the same app. It's a really super simple e-commerce app. But it breaks out the shopping cart, the authentication, the catalog, all as different microservices that run independently. So hey, look, it worked. This is the page, and I can come up here and I can add stuff to my cart. So I can say, okay, add this to my basket, and there's my basket. I can go over here. Maybe. I can get to the basket. Oh, it worked. So I don't know why it's so big. Oh, it's because the monitor's a horrible resolution. Okay, so then I can check out and the thing will go away. If I log in. So yeah, it all works. And then I can see my orders. It's there. Look, I just ordered this thing. So it's pretty simple, but it works. And this one's, like I said, monolithic, meaning all one solution. The other one, eShop on Containers, also has its own book, ebook that goes with it that's free. Talks about how to do all the same type of stuff but architected using microservices and containers. So you can kind of see both. I highly recommend if you're thinking about going toward a microservices architecture, that you start with a monolithic application and then see where things make sense to pull out as separate microservices, rather than starting with a whole bunch of microservices and hoping that you picked right from the get-go and building from there. All right, other questions? Cool. Well, thank you very much. I'm going to turn it back over to Sam, and he's got some more things to say, I believe.
Great job, Steve.
Thank you.